Hey guys, this is Mr. C. In this video, we're going to look at comparing linear and exponential functions and see how their behaviors are similar and how they are not similar. So we have a couple problems we're going to do. The first one says two robots begin traveling at the same time and in the same direction. The distance traveled in x seconds is y feet. Robot A maintains its speed at 2 feet per second, while robot B doubles its speed every second. Complete the tables below. So this table right here, since it's 2 times x, is going to be for robot A, and robot B is going to be over here. So we're going to go from 0 to 6 seconds. So 0, 1, 2, 3, 4, 5, 6. And the same over here, 0, 1, 2, 3, 4, 5, 6. And we just need to complete the tables. So 2 times x each time for this table for robot A is going to be basically 2 times whatever these values are each time. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8, 2 times 5, 10, and 2 times 6 is 12. I'm gonna go ahead and use a different pen for the other one. For robot B, I'll change that to blue here. We're going to now take 2 and we're going to raise it to these powers because this one's doubling its speed every second. So 2 to the 0 is equal to 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power, 16. 2 to the fifth power, 32. And 2 to the sixth power is 64. So now we're going to go down here, we're going to look at our graph, and it says to take the graph, and we're going to graph the two functions right here to see what they look like. So robot A, robot B. So I'm going to label my graph like this. Here's my x-axis, here's my y-axis. And so for the x-axis, I'm going to skip one each time. I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and that's seconds. And for the y-axis, I'm going to go by ones each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so we're going to do some graphing. So let's do A first. So we have 0, 0, robot A, 1, 2. Let's see, 1, 2, yep, be right there. 2, 4. 3, 6, 4, 8, and it looks like it's going up this way and over 2. 4, 8, 5, 10, 6, 12. So it looks pretty good. And so for robot A, we can go ahead and connect those dots. And it's looking like it's going in a linear fashion, which makes sense. Robot B, however, is not. So robot B is going to be 0, 1, 1, 2, 2, 4, 3, 8, let's see, 3, 8, 4, 16 is right there. And the rest of those are going to be too big to put on the graph, the two y values over there. So when I graph this, I need to smoothly connect these dots over here. And it's going to dip down below and come back like that. And this is robot B. All right, so let's answer some questions based upon our graphs. For what times is robot A faster than robot B? And it looks like robot A is faster than robot B from 1 second to 2 seconds because that's the only place where the red curve is above the blue curve. So that would be 1 second to 2 seconds. Which robot will eventually accelerate the fastest? Obviously that's going to be robot B, because it's already going up, 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 and A is just kind of maintaining a steady velocity there while B keeps accelerating. Will robot A ever overtake robot B? Will this one ever overtake B? Well, once B gets in the lead, the answer is no. So what this tells you is that this exponential function for B is going to always, at a certain point, be above A. At some point, the exponential is going to beat the linear, or actually any polynomial curve, quadratic, linear, any of them. So the exponential one is always going to, in the long run, the exponential is always going to be the winner. Maybe not always, but in the long run, as x gets bigger and bigger, it's eventually going to be the winner, the exponential. All right, so that one is a really good example to show you guys. And now we're going to take a look at this one. And this one's a little bit more involved. Let's take a look. You're thinking about investing in 2 funds. To find the value of Fund A, you multiply 1.5 by the number of years the money has been invested. Fund B grows by a rate of 50% each year. And so as soon as you see that grows by a rate of 50%, that's telling you it's going to be exponential, because exponential functions grow or decline by rates and ratios. Let X represent the number of years the money has been invested, and let Y represent the amount of money that has been accumulated. Complete the tables below. So let's go ahead for Fund A. We're going to do this table, and we'll do that first. 0, 1, 2, 3, 4, 5, 6, 7. And it says that X is the number of years, and the Y values after you multiply. So 1.5 times 0 is still 0. 1.5 times 1 is 1.5. 1.5 times 2 is 3, or 3.0. 1.5 times 3 is 4.5. 1.5 times 4 is going to be 6.0. 1.5 times 5 is going to be 7.5. 1.5 times 6 is going to be 9.0. And 1.5 times 7 is going to be 10.5. All right, now for Fund B. Okay, so here I'm going to have to use a calculator probably. So same number of years, 0, 1, 2, 3, 4, 5, 6, 7. And so now, and I'm using purple this time for B. I meant to use blue, but I got purple. Now we got 1.5 to the 0 is going to be, and we'll do this in a calculator every time. 1.5 raised to the 0 power equals 1. 1.5 to the first power, we know what that is. Just 1.5 again. 1.5 squared is 2.25. You could round that to 2.3 if you wanted. 1.5 raised to the third power is about 3.375. 1.5 raised to the fourth power is about 5.0625. 1.5 to the fifth power is about 7.59375. 1.5 to the sixth power. And now we get some big long numbers. About 11.39, and 1.5 to the seventh power is about 17.1. Okay, so now we can graph those. So we'll graph Fund A first. And let's go ahead and take our graph here, and let's label it x-axis, y-axis. We're gonna go by, skip one each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for the y-axis, we're going to go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so let's go ahead and do some graphing. Here's the first one for A. 0, 0, it's right there. Okay, 1, 1.5 is going to be about right here. 2, 3.0, 1, 2, 3, about right there. 3, 4.5 is going to be about right here. And just to make sure I did that right, 1, 1.5. Yep, that didn't look right. So that one is off. Okay, 4, 6.0. Okay, let's look at behavior. It looks like it's going up a box and a half, then over. A box and a half, then over. A box and a half, then over. And you can use the pattern to just get the rest of these. Because it is linear, and that's how linear behaves with a slope. All right, there we go. If you kept going, which we only went up to 7, but that's okay. If you keep going, that's fine. We'll connect our dots. Okay, that's Fund A. All right, now we got Fund B. Okay, so Fund B in purple this time. 0, 1. Here we go. 1, 1.5. Same place that is. 2 and about 2.3. So maybe here. 3, about 3.4. 4, a little bit bigger than 5. 5, about 7.6. 6, 11.39. Which that's going to be about, there's 11, there's 6, so 11.39, about right there. And 7, 17.1. So that's 17. And 17.1 would be just a little bit above, so about right there. So it looks like this curve is kind of going like this. If I connect all these dots as smoothly as I can. And there's Fund B. All right, now answer 3 questions. After how many years will the 2 accounts have the same amount of money? It looks like after 1 year, they both have 1.5. So 1 year, and then they meet again somewhere over here in that area, somewhere between 4 and 5. All right, I don't really know where that is, between 4 and 5 somewhere, but somewhere in there they meet. So I would say it's not 4, it's probably closer to maybe 4.5. So about 4.5 years. Okay, we could figure that out if we set the 2 equations equal to each other and solved, but we're not going to do that. All right. Which account holds more money between years 1 and 5? So between years 1 and 5, and that's assuming that that's about 5, that would be A. So between years 1 and 5, the red line or curve is ahead of the purple one. So that would be Fund A. And which account will hold more money after 5 years or about 4.5 years? That's definitely Fund B. Because that one is going to grow faster and faster, always more than the linear. Because it's always, exponential is always going to win in the long run. So that's the main point of this entire lesson. All right, guys, so that has been comparing linear and exponential functions. So to remember to like my video, subscribe to my channel if you haven't already. We'll see you guys later. Bye.